this was. All right, so we start out with just a couple things that we've already gotten to, that average velocity is the change in position over change in time. And you will hear me go talk about time and change in time. Here's the thinking of when you can drop the delta in front of it. I know that the change in anything is going to be the final value minus the initial value. If we set the initial value to 0, because when you start the stopwatch, really depends upon what's convenient for the problem. So if we let the initial time be 0, then this just becomes delta t is equal to the final time. And since now I'm only talking about one time, I could just say, well, what the heck, let's just call it time. So you'll see in class I will try to, well, I'll flip back and forth. Sometimes I'll just say time, sometimes I'll say change in time. That's where the thinking comes from. Some textbooks will take it a little bit further, and they'll automatically start with the initial position at 0, and so they'll just talk about position over time instead of change in position. I try not to do that, and in 152, we get into an issue of electric potential versus voltage, where some textbooks just say, let's just make the initial value 0, and they simplify it. So the art of simplifying, but not too much. So anyway, we're going to start out with these, and we're going to derive what I refer to as the cake formulas, which is somewhat redundant. And let's get this on, please. So I'm going to start out with this idea of constant acceleration. So if the change in acceleration over change in time is 0, in other words, acceleration doesn't change with time, then acceleration is constant. So that is just one way of writing acceleration as constant. So if we're dealing with constant acceleration, there are certain formulas that deal with motion, and from the Greek word for motion, kine, we have kinematic equations. So if you hear me or see me refer to cake equations or cake formulas, I'm referring to the constant acceleration kinematic equations. This is not a common acronym. It's something, unless it was some subliminal suggestion from the past, you will not find this in any textbook. But there's cake formulas, and then there's going to be the angular cake formulas in 2 months. All right, so we're going to start out with this idea of constant acceleration. So first off, how realistic is constant acceleration? Well, it's a stepping stone, but also if I drop this marker, the acceleration as it falls is relatively constant. So it is not completely unrealistic. All right. So I'm just going to write acceleration. Change in velocity. What is change in velocity?
The change in velocity. Velocity minus the velocity of the final velocity to the initial velocity.
Which one do I subtract from which?
The final is minus from the F is first minus initial.
Okay, final minus initial.
Yes.
So V final minus V initial over, and this is a situation where I'm just going to write time. If you want to write delta t, it is perfectly fine. I'm just going to abbreviate it. And that's the one I want? Apparently not. Oh, something happened. Nope. All right. I'm now going to multiply both sides by time. So acceleration times time is equal to V final minus V initial. And because I know the final form I want, I'm gonna add the initial velocity to both sides, and so I end up with my final velocity is equal to my initial velocity plus acceleration times time. That is our first cake formula.
So you've just rewritten that equation?
Yep. Into a form that you're more apt to see. But it is based on this idea that if acceleration is constant, that's the formula for the velocity. And so a quick problem. A car starts at negative 40 meters per second. It accelerates uniformly at 3 meters per second squared for 7 seconds. What is the car's final velocity? So just a quick sample type problem. Big things is when you're solving these problems with any of the kinematic equations or any of the kinematic problems, there's 5 quantities that you're looking for. You have displacement, you have initial velocity, you have final velocity, you have acceleration, and you have time. If you know 3 of these, you can find the other 2. So first off, what are we given here? Which of these 5 quantities are we given?
Velocity initial.
All right, which is?
Negative 40 miles per second. Or meters per second.
There you go. All right, so negative 40 meters per second. What else are we given?
Acceleration,
Which is?
plus 3 meters second squared.
It's quite possible I didn't hear it, but you trailed off at the end.
The plus 3 meters per second squared.
There we go, yep. And? All right. Now the quick plug and chug version, as we go to this formula over there, we're asked to find final velocity, and wow, we just happen to have an equation with that. So my final velocity is negative 40 plus 3 times 7. Now notice I did not stick units in at this point because I know what the final units are going to be. Well, as long as these are in international standard units, which involves meters and seconds, what will the units of final velocity be?
Meters per second.
I heard somebody say it. Say it with great confidence.
Meters per second.
Yeah.
There we go. And so it becomes a math exercise. So I got 21, negative 40, so I got negative 19, and make sure the units are there at the end. And by the way, 40 meters per second is 85 miles an hour, or ish. Did this car speed up or slow down?
Slow down.
Why do you say it slowed down?
More. Speed up.
You say it sped up?
Yeah,
Why do you say it sped up?
because it went from negative 40 to negative 19, like it went up, like, more. It's going more to the positive end. I don't know how to explain it.
What does the negative mean?
Less than 0.
Negative means 0?
No, less than 0.
Less than 0. There's a better way of defining it in this particular context. What does the negative mean?
Going left.
Why left?
Well, if it's on a plane, it would be going left. Like if you had a origin.
Okay. Like an origin.
It's gone left,
Why are you saying it's going left?
because it's negative, and it's going,
Well,
Going backwards?
why do you say backwards?
Put the car in reverse and then you're going negative, so it usually means you're going back.
now I say it's going forwards.
I don't know if it's going backwards or forwards, actually.
Okay.
Tristan, did you say something? I heard a voice from back there somewhere.
Getting closer to the origin?
No, it's not getting closer to the origin. That I can safely say. That exercise we went through on Tuesday,
Where you're walking.
yeah, what did negative velocity mean? Skylar?
No.
Negative. Negative velocity means positive acceleration?
No, not necessarily.
Not even close enough.
In this case, there happens to be positive acceleration and negative velocity, but
The car's actually exploded, so we don't even have a metric for understanding.
the exploding car would be the conservation movement of what chapter?
Awesome sauce.
We're not there yet. Is my velocity negative or positive or zero right now?
Negative.
Negative.
Why?
Because of left of the line.
So why is going that negative?
Cause, yeah, cause it says so.
Where did I say it?
It's just like,
Problem, negative 40.
That tells nothing about whether it's going left or right.
it's just a universal rule.
No, it is definitely not. That's what I'm trying to break you of right now. It is not a universal rule that negative means any particular direction. What does the negative direction mean? It's much simpler than you're thinking.
Not positive.
Yes.
Oh! Call me Einstein. Oh, yeah.
What is the positive direction?
Other.
Not negative.
Sorry, you don't get credit twice for that. Somebody almost said it over here, or did say it. What's the positive direction?
Not negative.
The other direction?
Okay, let's just establish positive, negative, or opposite directions. How do you know which way is the positive direction?
Plus sign.
It doesn't have. It does not have it. Therefore, it is-
How did you know which the positive, on Tuesday, how did you know what the positive direction was?
Because we had an origin and we were going to the right of it.
That's, why was that the positive direction?
Cause you defined it to be that way?
Yes, because I said so on Tuesday. That was,
Oh.
all right. Have I defined the positive or negative direction here?
Yeah.
No.
No. No, we haven't.
If I, thank you, if I did, I'm not sure where I did that.
Oh, so just because you have the signs doesn't, okay.
Yeah, it's going, whatever the negative direction is, it could be to the right, left, up, down. I don't know. All I know is, there is one thing I should have added here, that this is a linear problem, that it is traveling along the line. But it starts out going in at negative 40 meters per second, in the negative direction, whatever that is. If you visually want to think that's to the left, fine, right, fine, up, fine, towards you, away from you, whatever, just, it's in some direction. The negative is telling us a direction. It starts out at 40 meters per second in that direction. It ends up at 19 meters per second in that same direction. So if it's going from a speed of 40 meters per second to 19 meters per second, speeding up or slowing down?
Slowing down.
Another way that you can know it's slowing down, velocity and acceleration are opposite signs. Now, here's a brute force method, and I don't recommend that you do it, but this is just another way of picturing it. 0, 1, 2, 3, 4, 5, 6, 7. These are in seconds. This is meters per second, and that is -40. So an acceleration of 3 meters per second squared says that acceleration 3 meters per second squared is the same thing as 3 meters per second per second. In other words, my acceleration is changing by positive 3 meters per second every second. So after 1 second, it's going -37 meters per second. -34, -31, -28, -25, -22, -19. Hey, we ended up in the exact same spot. Now, one of the reasons why this is not particularly convenient is that if I said, what is the velocity after 50 seconds, it would be quite a while to crank that through. Hopefully, you're not gonna make a mistake. Or, what's the velocity after 2.5 seconds? Or 2.37 seconds. Then you have to do some interpolation, or just plug into the formula. Questions for here before we add a second one? I'm going to change this slightly. I'm going to make it 8 seconds. So, yeah, before I step on it. Make that 8 seconds, so that's 8. And so that would be 16. So we're gonna add one more. Over the course of these 8 seconds, what is the average velocity? And if you're thinking, how would you find that? Well, I'll ask you, how would you average numbers?
Add them up, divide by the total.
Somebody do it, or it's more than one person do it, probably be nice. When someone has answers, shout out. Take chances, make mistakes, get messy.
When I added all the velocities up, and then divided it, I got 26.875.
What did you divide by?
8,
Why 8?
because we had 8. What'd you do 9? Because we have 0.
They're 9 numbers. That's a common error.
-28 is our average velocity. And I'm right.
So nice confidence there.
Wait, wait.
So -28?
Sure is. No doubt about it. -28 meters per second.
There we go. You recognize your missing units look. Now, I think there's probably another calculator error in there somewhere.
Oh yeah, I didn't put in negatives. I just did positives.
All right, so you added up all 9 numbers,
Sure did.
divided by 9.
Sure did.
Why?
Because that was what. Huh? So, when you said, how do you find normal average numbers? I said, oh, I got you. Out of all the numbers, divided by the total number of numbers. Again, with next to it. All good and dandy.
Yeah, and that is the right answer. His confidence was well-founded. Well, what's so special about looking at it every second? Because I got rid of, did it every 2 seconds. What's my average now? me to say that with more confidence, or just let other people figure it out first? Ellie?
Wait a minute.
Is it still the same?
You're asking now, before you said it like a statement.
Okay.
Go for it.
It's the same.
And Ibrahim, what are you gonna ask?
I was gonna say, I just took out all of them except the first one and the last one, and I did the average for that, and it was still the same.
What?
What's going on?
There's nothing special about every second. If you're gonna do it, this adding them up, just so, as long as the time increments are the same, so every 1 second works, every 2 seconds works, every 4 seconds works, every 8 seconds works. It turns out if acceleration is constant, and that's key, if acceleration is constant, all you really need to do is look at the first and the last one. So we have our second cake formula. Probably should write these someplace, put them over here. So we had V final equals V initial plus AT. And we now have that my average velocity is equal to V initial plus V final divided by 2. Actually, that is not really one of the cake formulas. That's something that we're going to use in the cake formula. So when I'm looking at average velocities, if acceleration is constant, this is true. If acceleration is, I don't care, that's true. This is always true up here. Average velocity is always change in position over time, or displacement divided by time. Average, if acceleration is constant, that is true. Questions before we combine some stuff? So I've got my average velocity is equal to the change in position. Just keep it as just, keep it as displacement over time, which is equal to